if you want clarification on that, if you want some recommendations on that, or if you need help with some structure, you just let me know. Okay, we lost somebody.
Yes, at first I did have that problem.
Yeah.
Kind of need a little instruction on it because it's been a while.
Okay. So so in general, you always review. Just a moment. In general, you always review the basics. You always make that your like level 1 information, right? And that's why I create this March 2023 basics. I just call it March because that's when we started. But you always start with the basics because and for us that means anatomy and physiology and kinesiology. Without those two, there would be no pathology, right? And understanding how massage hand techniques would be much more difficult. It just helps everything. It's necessary for everything. Okay. So and then anything that feels in the basics. Okay, so let me back up. So the basics are how the body is put together. So for us, that's orientation. What's up, down, lateral, medial, front, back, etc. Like, what are all those terms, right? So you start to build your vocabulary to express those things, right? Like the body is looked at from this way, and that's called anterior. For the hand, it's volar. For the foot, it's dorsal plantar, right? So you practice. That's why I have you practice those almost every session. And then how the body moves, like how the body is meant to move, and also the languaging around that. A lot of what you're getting ready for is languaging. It's to be able to express accurately, so that you don't have to say, instead of saying a muscle contracts, you can say there's a concentric contraction, right, or a shortening of the muscle, right? And then after those things, you start to get into the stuff inside the body, right? So how is the cardiovascular system put together? What are the structures, right? And then what do the structures do? And a good way to do that would be to cycle through 1 or 2 of them every day. So there are about 11 or 12. Let's just say 12. Okay, the 12th one is the immune system. It's not an organ system, right? It's made up of a couple of different organs, and it's considered a body system, not an immune system. So some people will say 11 only, some people will say 12.
Okay.
So if you're going to study like 5 days or 6 days a week, which I recommend because you should be taking at least 1 day off. At least 1 day off to rest. Your brain works when you rest, and it does kind of work that it can't do when you're putting things in there. It's called dissociation. Right? It basically goes in and files and cleans everything up so you can get to it quicker. So if you're going to study like 12 body systems over the week and you have 5 or 6 days, that'd be about 2 body systems, maybe 3 body systems a day. The muscular system, the skeletal system are the largest. They take up and the endocrine system, right? But maybe you are a former nurse or home health aide or acupuncturist or biology teacher, maybe you have knowledge of one of those systems a little more deeply than the others, so you kind of like got that information pretty easily. So then you focus on the ones that you don't know. So over time, over like a couple of weeks, you'll start to figure out where your weak points are in terms of the basics, in terms of understanding how the body's put together, in terms of the 12 systems. When you learn your 12 systems, you have to learn the anatomy and physiology. All right, and then that's just like the first top level. I would call that level 1. I should organize all this stuff for you guys, but it's challenging for me just to keep up with everything right now.
Yeah.
So the basic information I would say would be how to get oriented or talk about the body, up, down, medial, lateral, etc.
Okay.
Superior, inferior, medial, lateral, all the orientations, and then the movements of the joints, and then the 12 body systems. After that, you start to get into really specific stuff. I would call like the second level of information that's specific to the muscular system, to the bones, to the joints. This is stuff that you guys specialize in, right? So those would be all the stuff that we've covered about muscles, and we're gonna I think just about wrap that up today. So you'll get to like the full. We'll finish laying out all the information for the muscles that you need, right? And then all the specific information for the bones. You've gotten a taste of that already when we have looked at the scapula. What are the bony features on the scapula? Where do the muscles attach? How do we know we're looking at the front versus the back of the scapula? And then we've looked at and then we did the same thing for the pelvis, right? Like this upper half is called ilium, the lower half is called the ischium, and then building out more specific information, like where do the different muscles attach? And then that's like your second level of information, right? Like what do the fibers of this muscle look like? Where does it attach? What motion does it do in the joints around it? And then the third level of information down from there would be which bone is moving and which bone is not moving, right? Is this the prime mover of this movement of like flexion extension, or is it a synergist? That starts to get really specific, right? Which muscle opposes it? Like, how does it work with the structures around it? How does it work with the bones around it? How does it work with the muscles around it? And then, hopefully along the way, you understand some basic stuff like from anatomy, like whether a muscle is striated or smooth, voluntary or involuntary, right? And yeah. And then there's a level of information below that, like more specific than that, which you start not to need. And that gets into like specific aspects of how muscles use glucose, specific aspects of how hormones interact with muscles, right? That's like almost biochemical level. You don't really need that.
Okay.
So that's 50% of the exam. All right. So that's like the science-based stuff. The other is like the ethics, legal, business stuff, because they're going to ask you like, what's the first thing you write down for a business, what are those things called? Business plan or whatever, right? What's the definition of abuse? What is transference between client and practitioner versus non-transference? What's the difference between a certification and a license? They're going to ask you those things. Those things, in my opinion, you can learn easily enough by doing practice questions. And the AMTA is a fine and a free example of that. So if you want to look up some specific stuff, mostly it's going to be, when you run into stuff like that, it's mostly going to be around like terminology, to help you remember things. Like, yeah, that's enough of that. And then there'll be some energetic medicine, like complementary and alternative medicine, but there's not too much of that on the exam. There will be a little bit, but not too much. And then the massage techniques, I would say, is the third category, right? So your first category is like the sciences. Second category is the professional stuff. And then the third category is massage techniques. The massage techniques are going to be mentioned specifically in the pathology section. Each of these sections is between 10 and 18% of your score. So the pathology session will have a small percentage that is hand techniques, but you want to know those hand techniques. And we definitely will be going over those. I have a chart in the MBLEx Google Drive. I have a Google Sheet, which is a spreadsheet with most of the hand techniques, with the mechanical and the reflexive effects. And you just need to get used to those. You just need to like get familiar with those. And then as far as like how to study, there's different ways of studying, and you have to find what works for you. For me, reading something and repeating it and moving, and sometimes asking myself, do I really understand this? And even trying to like mock teach it works really well. Other people need flashcards, right? They need to see, they're very visual, so they need to see things over and over and over again, and having the information just on a page they know is not going to work. And maybe they need to find like a favorite video for the harder concepts and watch that regularly. But for the most part, being successful in preparing for an exam is being able to imagine or to see all the information laid out and to be able to break it down into a couple different sections, a couple different levels of information, and then to cycle through it regularly.
Okay.
You know, so definitely do your hard sciences, definitely do your sciences every day, even if it's just 5 minutes to review your orientation terms and or joint movements, or like muscle directions, you know, muscle histology. Even if it's just 5 minutes to do that, make sure you touch on that every day. And then you cycle through the other stuff, the professional stuff, the hand techniques. Am I omitting something? Professional stuff, hand techniques, and energetic medicine. Cycle through that other stuff regularly.
Okay.
You know, it's challenging. You can't prepare for everything. You can't learn everything, but you know, you just have to try. You just have to try. Yeah. Okay. So
thank you.
yes, let me just clean off my screen. Thank you for asking. Let me just clean off my screen before we stop. Before we start. Start video. Is that better? Maybe. Okay. Right. So let's take a look at let's do our cardio review. So you can mute yourselves, or you can leave yourselves unmuted if you want to. So we're going to refer to this visual here. Please let me know if you can't see my screen. I should be sharing my screen. We're going to refer to this visual here, and I recommend that you just repeat after me. So let's go through this like 3 times. Okay. So deoxygenated blood comes in through the superior and inferior vena cava and enters the right atrium. Deoxygenated blood, superior, inferior vena cava, right atrium. Right atrium, tricuspid valve, right ventricle. And you can go like this with your hands. So A on top and V like a valley on the bottom. Atrium on top, ventricle on the bottom. Right ventricle through the pulmonary valve into the pulmonary artery. Right ventricle, pulmonary valve, pulmonary artery. Pulmonary artery to the lung. From the lung to the pulmonary veins. Pulmonary veins into the left atrium. This is oxygenated blood. Left atrium through the mitral valve, left ventricle. Left atrium, mitral valve, left ventricle. Left ventricle through the aortic valve into the aorta. Oxygenated blood out to the body. Remember that both the superior and inferior vena cava and the aorta, they have upper and lower. Their purpose is to circulate blood to and from the upper body and the lower body. That's why there's a superior and inferior part to both of them. So now you just simplify the terms and you go through it. And then, yeah, that's the second step. So deoxygenated blood, superior, inferior vena cava, right atrium, tricuspid valve, right ventricle, pulmonary valve, pulmonary artery, right ventricle, pulmonary valve, pulmonary artery. Pulmonary artery to the lungs, oxygenated blood into the pulmonary veins, pulmonary veins into the left atrium through the mitral valve, bicuspid valve, into the left ventricle through the aortic valve into the aorta, left ventricle into the aortic valve into the aorta. Okay, now let's mix it up a little bit. Okay, so let's just take things and let's take 2 or 3 structures at a time and go through them. And then like we'll start on the right and then we'll shift to the left. And then we'll go to like the lung and then we'll go to the deoxygenated blood that's coming in and the blood that's going out. So we'll mix up the order, but we'll keep the correct structures paired in 2 or 3 items at a time. So let's start with the lungs. Oxygenated blood into the pulmonary veins. deoxygenated blood into the vena cava. Deoxygenated blood, superior, inferior vena cava. Pulmonary vein, left atrium, mitral valve. Pulmonary vein, left atrium, mitral valve. Right ventricle, aortic valve, aorta. Right ventricle, aortic valve, aorta. Superior, inferior vena cava, right atrium. Pulmonary vein, left atrium. Right atrium, tricuspid valve, right ventricle. Right atrium, tricuspid valve, right ventricle. Left ventricle, aortic valve, aorta. Oxygenated blood. Left ventricle, aortic valve, aorta. Oxygenated blood. Right ventricle, pulmonary valve, pulmonary artery, deoxygenated blood. Arteries away from the heart, veins to the heart. Arteries away from the heart, veins to the heart. Okay. Yeah, so let's move on. Maybe I'll test you guys on that a little bit later. Like during another class. Let's review this thing here. Okay. A whole muscle fiber is made up of many smaller bundles known as fascicles. Each fascicle is made up of many myofibers. Myofibers contain myofibrils. Myofibrils contain myofilaments. A whole muscle contains fascicles. Fascicles are made of muscle cells, myofibers. Myofibers are made of myofibrils. Myofibrils are made of myofilaments. Myofilaments are made of actin and myosin. Actin and myosin. Now let's start there. One of your learning objectives or your study goals is this looks like it may be a little small. A second. One of your study goals is to understand the anatomy of a skeletal muscle, and they ask you that twice. They say, identify various organizations of muscle fibers in skeletal muscles, and they say, identify the structure of muscle fiber at the microscopic level. I think when they say microscopic level, what they mean is breaking the muscle down into what it contains: fascicles, myofibers, myofibrils, actin, and myosin. And I think what they mean when they say various organizations of muscle fibers in skeletal muscles, I think what they mean are orbicularis muscles, rectus muscles versus pennate muscles, unipennate, bipennate, etc., the shapes of muscles. So we're looking at the structure of muscle fibers at the microscopic level. With everything with the FSMTB, I have to decide what it is that they're saying, because they're sometimes a little bit not specific enough, and that is okay. That's okay. You can't know everything, and you might as well pick something and start woodshedding it. So this is a muscle, right? Here's a tendon, and the red belly, also called the gaster. Muscles have a gaster or a belly, and then they have a tendon. They have an origin and an insertion site. So here's the tendon, and then there's the muscle. And every muscle is made up of several fascicles. So these are fascicles. So there's a big one that's extended out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 11 fascicles. Each fascicle is made up of many myofibers, muscle fibers. And every myofiber is covered with a sarcolemma. Myofibers or muscle cells, are the cellular, or they are cells, so they contain nuclei, They contain mitochondria. You can see mitochondria in the drawing here, and nuclei over here. And then down here, you have blood capillaries. So there's a blood supply. And every myofiber is made up of myofibrils. If we take out one myofibril and expand it, it looks like this down here, right? So here's a muscle cell. That's a myofiber. And each myofiber contains many myofibrils. The myofibrils are the ones that have actin and myosin filaments. We'll look at those in a minute. So you have muscle that's made up of fascicles. Fascicles are made up of myofibers or muscle fibers, muscle cells, myofibers. Myofibers are made up of myofibrils. Muscles, fascicles, myofiber, myofibril. Muscle, fascicle, myofiber, myofibril. Then you have to remember that just leaves sarcolemma, actin, and myosin to remember. The sarcolemma, sarco means muscle, and lemma means like sheath or covering, lemma. So the sarcolemma, you have to just identify which structure it goes around. That goes, it's the covering for the muscle fiber. The name of the muscle fiber is the myofiber, muscle fiber or muscle cell. And then what else does that leave? That leaves actin and myosin. So the smallest unit of muscles is the myofibril, and the myofibril contains myosin and actin. Should be on the next page. Yeah. So here's a larger view. Is this the largest one I have? Yeah. Here's the largest view. These are myofilaments. See, I'm sorry. This is a myofibril, and myofibrils contain myofilaments. The myofilaments, see these dots? Myofilaments are all these dots and all these lines, right? The dots and the lines are the same. The dots are the cross section of the lines. The dark ones are myosin, and the light ones are actin. Okay, hold on just a second. I'm having some seasonal allergies, so I just need to take a pause for the cause. Okay. Thank you for your patience. Okay, so this myofiber muscle cell is made of myofibrils. And if myofibrils are blown up, you see that there are many myofilaments. There are thick myofilaments, which are myosin, thick myosin filament. And there are thin myofilaments, which are actin. You can tell the actin and the myosin apart because the thick ones have these darker, thicker bands in the rendering, in the drawing, right? And the thin ones have the thinner, like Y-shaped bands in the drawings. And the striated appearance of a muscle, the striated appearance of a muscle cell or a myofiber comes from the areas where these bands overlap. So you have bands going the whole length of the myofibril, and there are certain areas along the length of the myofibril where the myofilaments overlap, where the myosin and the actin overlap, and that creates stripes or striations. So again, if you practice the breakdown from large to small, it's the whole muscle, fascicles, muscle cell myofibers. Muscle cells are myofibers. I put the terms in a row there so you see that they are the same. Muscle cells or myofibers, myofibrils, myofilaments, actin, and myosin. The key to learning something like this, I think, is to look at the picture And to say it to yourself, muscle, fascicle, myofibril, myofiber. No, see, I skipped it. Muscle, fascicle, myofiber, myofibril, myofilament. And then to close your eyes and to picture each item: muscle, fascicle, myofiber, myofibril, myofilament, actin and myosin. And it really is just a matter of practice. I think for you guys, it's probably going to take you like practicing this over 2 days, like less than 10 minutes on Sunday and a Monday. And then Tuesday, you'll find that you have it really, really solid. But it's definitely the kind of thing, you want to take 30 seconds once you have it in your mind. You definitely want to take 30 seconds to go through this like 3 times, just like the order of the blood flow. You want to have this down, right? Are there any questions about the muscle? Nope. Okay, so this is histology or the microscopic level. And then the structures in the muscle cell, the myofiber, that I want you guys to really have down are the essential parts of any cell. So that's the nucleus, the cell membrane, which is called the sarcolemma, and then the mitochondria that are in there. And there's all the other cellular organelles, like lysosomes and endoplasmic reticulum, and all those are also inside the myofiber. However, they're just not pictured here. Is there anything else that we want to look at before I move on from that? Okay. Okay, one of the first things that they ask you to learn in the FSMTBE study guide for the MBLEx is to understand the effects of massage on the muscular system. They put that statement at the beginning of almost every body system and at the beginning of almost every section, right? Whether we're talking about like a special population or whether we're talking about the muscular system, they say understand the effect of massage on, right? On the circulation, on the muscular system, etc. This is not so easy to find, right? Some of it is kind of almost intuitive knowledge that you've absorbed from your studies, your time in the classroom, listening to other clinicians talk about how hand techniques or how massage in general affects the body, this, that, and the other aspect of the body. It's some of it, it would be good for you to dig for the like deeper levels, more specific amounts of information. The more specific you go, in my opinion, the less likely, this is just my opinion, I don't know, but in my opinion, the more specific you go, the less likely they are to ask you about it as it relates to this specific question. How does it affect the muscular system? So I think it's fine for you to think broadly. So what do we know about massage and how it affects the muscles? Well, broadly speaking, it loosens them, makes them fluid, separates structures from each other. It increases the blood flow. It causes inflammation, right? It warms, it loosens, it moves. So some of the ways of saying that would be that it increases range of motion, which it does for both the muscles and the joints. Range of motion is both the extensibility or the pliability of the muscle, the stretchiness of the muscle, as well as the capacity of the joint to move. That's called the physiological range of motion. The ability of the joint to move is called the physiological range of motion. And the range of motion the joint has, like when you're completely healthy, is the anatomic range of motion. If you have an injury, your physiological range of motion in the joint is less than your anatomic range of motion. If you go to physical therapy, you get your physiological range of motion increased. Or if you go to massage therapy, you get your physiological range of motion increased, right? Movement. Okay, so massage increases range of motion, it decreases stiffness, it increases blood flow, and it increases muscle temperature, muscle temperature. So as you're reading stuff like this, that's kind of like, very superficial layer of knowledge, make a note to yourself if something surprises you. If you read something and it's like, oh, I never heard that before, that's interesting. Or if something seems counterintuitive, like, huh, it does XYZ, I would think the opposite. Then that's one thing that you want to review for the next few days, like for a few days until you have it cold, right? Okay, increases proprioceptive accuracy. So proprioception is your ability to know where the horizon is and where your body is in relationship to the horizon. It's what tells you as you're falling. It's what tells you that you're falling and about to hit the floor. It's what tells you that you're upright and not about to fall. Proprioception and the accuracy of that, by the way, decreases as we age and as we move less. People who age, they tend to move less. If you move less, you challenge your sense of proprioception less. So really old people, that's going to be me in like a couple decades, so I better stop saying that. So like people who are in their septuagenarians, octogenarians, etc., they have a difficult time discerning the visual distance from the ground to their head and feeling their relationship with the horizon. So older people, as they start to fall, they don't realize it. They can't feel it the way that younger people can. They only realize that they are close to the ground when they're really close to the ground, which is why falls are such a big deal. And it's why movement is such a big deal for older people. You know, even like you see like the people in the pool doing water walking, like super gentle exercise, you know, that's like completely valid. I mean, anything that you can do, any movement that you can do is beneficial. Okay, I'm diverging, I'm sorry. So proprioceptive accuracy in athletes who have overtrained, done some temporary damage to their muscles, has been shown in research to increase after massage, right? Proprioception is your relationship to the ground and the horizon. It's also your knowledge of the angle of the joints. So that increases with massage in clients who have overtrained. Also, there's some weakness after overtraining because there's some muscular damage and some inflammation, etc. And massage flushes out the inflammation and it wakes up the muscles and kind of wakes up the nervous system. It also increases muscle strength in individuals who have overtrained. Of course, it releases trigger points. That's one effect. Trigger points are specific to the muscular system. It breaks down adhesions and it frees up the fascial bags and the muscle fibers. If you guys don't know what any of those structures are, please ask, and I'll talk about them a little bit. But I think most massage students, you guys can just absorb. Okay, we're going to go back to the beginning now. This is going a little slowly, so let me just get the film strip up. So the anatomy of the muscular system, the anatomy is how it's put together, and the physiology is how it functions. For muscles, a lot of that is how they fire, but the statement is not a complete statement. It's how they fire and how they move and their effects on things around them. So what's their relationship with muscles on the other side of the bone, antagonist, agonist, right? What's the difference between a concentric and eccentric, right? What is shortening and lengthening? How do they act as levers? How do they pump the blood, right? How do they affect other structures in the body? Just a reminder, there are 12 body systems. You guys can look at that if you want to. We looked earlier at muscle fibers. Muscle fibers, can somebody unmute? Dominique. Hi, Dominique.
Hello.
Hey, what part of the muscle are muscle fibers? Are they like the bundles that make up the muscles, or are they the muscle cells themselves?
The bundle.
Okay, the bundles are called fascicles that make up the muscles, and the myofibers or muscle fibers, those are actually the cells, right? So repeat after me: muscle, fascicles,
fascicles,
myofibers or muscle fibers.
myofibers or muscle fibers?
Yes, excellent.
Okay.
So when we look at thank you, Dominique. When we look at muscles, what we see is this big muscle belly, and inside are all these fibers, inside are all these fascicles, and the fascicles are made up of myofibers or muscle fibers. There are basically two areas where fibers are distributed in the muscle. One is the outside, the belly that we see, and the belly does most of the work. Those are called extrafusal muscle fibers. They're outside of a structure called the spindle. So this gray structure, this one's a little bigger. This gray structure is a spindle. Looks kind of like a corn husk or a lemma, like a lemma. A lemma is named after a corn husk type structure, at least. So this is like a sac or a spindle. I don't know why they call it a spindle, but that's what they call it. They call it a spindle. And inside the spindle, there's a smaller amount of muscle fibers, which are weaker, and they have sensory nerves wrapped around them, sensory nerves innervating them. And the job of these muscle fibers, called intrafusal muscle fibers, is to sense the amount of stretch on the muscle and the speed of the stretch or the rate of the stretch. So you can stretch your muscle by, for example, you can stretch your muscle by extending the range of motion as far as you can and lengthening as far as you can, right? But you can also, we also stretch muscles when we simply lengthen the muscle fibers. That's stretch. So if you have something really heavy in your hand, or you know, sometimes you catch something, or you pick something, you catch something that's heavier than you think, and all of a sudden your arm has to extend really quickly. That is a fast stretch of your biceps muscle. And it's the job of the intrafusal muscle spindle fibers to gauge that stretch and to determine whether or not it's going to tear some of the muscle fibers, right? You can imagine, like, if you tear muscle fibers, if you tear living cells, some of them die, right? So it's a big deal to the body. So to stretch or to stretch quickly can be dangerous. And in that case, what will happen is the intrafusal muscle spindle fibers will send a message to the nervous system, the central nervous system. The central nervous system sends a message back that inhibits this muscle, the antagonist, and allows the muscle to go the other way. So we're stretching quickly or too quickly, there's danger, and it's the job of the intrafusal muscle fibers to do that. So, and we'll get into the specifics of all that. I just wanted to give you an overview. So we have the muscle fibers, which are the part we think of as the prime mover, as the strength part of the muscle. They make up the most mass of the muscle. And then we have the muscle spindle fibers, which are inside the muscle spindle. The third feature we're going to talk about is the Golgi tendon organs, and we'll talk about those last. So I'm going to start stacking terms in for each of these structures, and the reason I'm doing it this way is so that you can be familiar with the words. Like I said, a lot of being able to take an exam successfully is having the vocabulary, having the languaging to describe the features. So let's just look at extrafusal muscle fibers first. So the extrafusal muscle fibers, extrafusal means situated outside the spindle. They contract, they do strength, right? Emmy, if something contracts and does strength, is it motor or sensory?
Motor? Would that be motor? I don't know.
Motor, that's right, that's correct. And if something senses stretch, is it motor or sensory?
Sensory.
That's correct. So we can refer to extrafusal muscle fibers as efferent motor or as motor extrafusal muscle fibers, right? When an impulse exits the central nervous system and travels through the motor nerves into the bicep, it's exiting the central nervous system, letter E, so efferent, letter E, it's an efferent impulse. When the intrafusal muscle spindle fibers sense a stretch on the biceps, it sends a sensory impulse through the nerves into the central nervous system. and it arrives at the central nervous system, arrives, letter A, afferent. Afferent. So afferent signals are sensory signals that go to the central nervous system. Efferent signals are motor impulses that exit the central nervous system. Efferent exits and goes to the body. Afferent arrives, comes from the body into the central nervous system. So we can call extrafusal muscle fibers efferent motor extrafusal muscle fibers. You will sometimes see it referred to as motor extrafusal fibers, right? But if you can get used to saying it this way, it'll be less confusing. Efferent motor extrafusal fibers. The efferent motor extrafusal muscle fibers are the largest part of the muscle, as we discussed. They are the main source of strength. They are the main source of the force. Let's see what's on the next slide. Just to give you some context, there's 50,000 of them in the entire body, 50,000 muscle cells in the entire body. Yeah. Okay. When you tap the patellar ligament or any ligament in the body, when you tap the patellar ligament, it stretches the muscle a little bit, just a tiny bit. And when you stretch the muscle, it's the job of the efferent fibers, the efferent motor fibers, to contract. And they provide the force that kicks the leg forward. Okay, now let's back up and go to the intrafusal fibers. So the muscle spindle fibers, also called muscle spindle cells, muscle spindle fibers, are intrafusal. That means they're inside the spindle. I always forget the name spindle. They're inside the spindle. Intrafusal muscle spindle fibers. Intrafusal muscle spindle fibers. So you guys say these with me. Intrafusal muscle spindle fibers. Intrafusal muscle spindle fibers. Those are situated inside the spindle, and they are sensory in nature, or they have sensory nerves. And the sensory nerves, when they send an impulse to the central nervous system, that's called an afferent direction because it's arriving into the central nervous system. Afferent sensory intrafusal muscle spindle fibers. So repeat after me. Afferent sensory intrafusal muscle spindle fibers. Afferent sensory intrafusal muscle spindle fibers. Their job is to sense stretch, the afferent sensory intrafusal muscle spindle fibers. And in each muscle, there's about 14 of them. I know it may have been a comparison between the number of extrafusal efferent motor muscle fibers in the whole body versus the number of afferent sensory intrafusal muscle spindle fibers in each muscle is not quite an accurate one or out of proportion, but that's the only information that I can find. So let's see. So now, before we go into like reciprocal inhibition and autogenic inhibition and all that, let's discuss a few real life contexts in which all of this would work. Okay, so I want you guys to imagine that you're at the doctor's office and look down at your knee now, right? The doctor's about to tap your knee, your patellar tendon, about to tap your patellar tendon with a heavy rubber hammer. And let me make sure everybody's here. Yeah. Okay. And you know from experience that once they tap the patellar ligament with something heavy enough, that involuntarily your foot kicks forward, your knee extends. Yeah. Hopefully we all agree that that's knee extension. And I want you in your mind to like feel that happening, right? Remember that happening. So what I want you to understand is that when you tap something or when you press on something, a tendon or a muscle, you're actually shortening it, because the two ends are not moving. The bones are not moving yet. You're just pressing on it. So whether you press or pull or deform something in some other way, like using a cup, for example, you're actually lengthening or stretching the muscle. You're stretching the tendon, which in turn stretches the muscle. It's all connected. That stretch has to be sensed by part of the muscle, which we know is, you fill in the blank, intrafusal muscle cells or extrafusal muscle cells. It's the intrafusal muscle cells. As the stretch is sensed by the intrafusal muscle spindle fibers, the intrafusal muscle spindle fibers send a sensory nerve impulse, which tells the nervous system about the stretch, to the afferent area of the central nervous system. Afferent impulses into the central nervous system. Maybe I'm not saying that quite right. And the nervous system says, extend the knee, kick the foot forward. So the efferent fibers come from the central nervous system, from your neck, down your back, through your hip, into your quadriceps group. The quadriceps quickly contract, and your foot kicks forward or your knee extends. Now, hopefully that is clear or clear enough. And it won't be confusing to you once we start looking at all these abstract drawings. So let's go to the drawing now. So this I don't even know what to call this shape. I'm just going to refer to it as a spinal cord shaped disc. So this spinal cord shaped disc is a section, one small section about like 1.5 inches long of your spine. So this is probably, since it's receiving and sending impulses to the leg, it's probably somewhere around like L4, L5. So what they did was they went down to L, the lumbar region, and they cut through it above, and they cut through it 1 inch below, and then they turned it, they like took it apart, and now you're looking down on it, so you can see inside. And when you look at the spine, what you see are a certain amount of white area and a certain amount of darker grayer area. So the white area, by the way, is white because it contains a lot of myelin, because the nerves in there, which I'm going to refer to from now on as neurons, not nerves, the neurons contain a lot of myelin coverage. And that makes the nerve impulses travel faster. The gray part is gray because there's less myelin. Myelin is fatty, and fat is a little bit white in color. Okay, so what do I need to tell you next to help you? Okay, so we're going to go back through the process now of the patellar reflex. All right, so when this rubber mallet taps the patellar tendon is connected to or part of the rectus femoris, part of the quadriceps muscle. It stretches the rectus femoris muscle, stretches it a little bit. The stretch is detected by which one, the intrafusal or the extrafusal fibers. If you said intrafusal, you are correct. It's detected by the intrafusal fibers, which play a sensory role. They pick up stretch and the speed of stretch. And they send an afferent arriving at the nervous system. They send an afferent impulse through an afferent sensory neuron into the central nervous system, into the spine, into the spinal cord. Once the afferent sensory impulse arrives in the CNS, central nervous system, the nervous system then has to decide what to do with it. And in this case, in the sudden lengthening of the rectus femoris muscle, the nervous system says, shorten the rectus femoris. It's lengthening quickly. Let's get it under control. Shorten it. In order to make that happen, it sends out 2 motor impulses, efferent motor impulses. One efferent exiting, letter E, efferent from the nervous system. One efferent motor impulse goes to the rectus femoris and contracts it. To facilitate the contraction of the rectus femoris, a second motor impulse goes to the hamstrings and inhibits the hamstrings. That's called reciprocal inhibition. So it's the agonist muscle, the rectus femoris, the agonist, which is contracting, shortening, and it's the antagonist, which is lengthening, relaxing, or inhibited. Please let me know if any of that is unclear. Okay.
Can you
Yes.
go over that antagonist and agonist again?
Yes, yes. And I'll do it here, and then I'll do it in one other place. So
Okay.
you have the rectus femoris, right? Touch your rectus femoris. It's right in the middle of the thigh, the front of the thigh, right? And that forms the patellar tendon. When the patellar tendon is pressed or tapped or stretched, there is a sensory impulse sent by the intrafusal muscle spindle fibers through their neurons that goes to the nervous system. And the central nervous system then tells the same muscle, the agonist, the rectus femoris, tells the agonist to contract. And it tells also the antagonist, the hamstring muscle, to inhibit, to relax, or to lengthen. So it contracts the rectus femoris, the agonist, contracts the agonist, rectus femoris, touch your rectus femoris, and it inhibits the hamstring, the antagonist, touch your hamstring. It inhibits the hamstring, the antagonist. Another place where you can see that is with the biceps and the triceps. So I don't have my camera on now. So just look at your own bicep, and there is a reflex at the biceps tendon as well that can be elicited through the same means, through tapping with the same kind of rubber hammer. So the same process happens where you tap or you press or you stretch the tendon, which stretches the intrafusal muscle spindle fibers. Those spindle fibers then send an afferent sensory impulse through the afferent neuron to your spinal cord. In this case, it'll be the section somewhere around C6. And then the central nervous system sends motor impulses to both the agonist and the antagonist, telling one to contract and the other one to relax or to inhibit. So the motor impulse going to the biceps tells the bicep to contract. The one that's contracting is the agonist. The biceps is the agonist. To allow the bicep to contract, the antagonist has to relax or turn off or inhibit. That's the tricep. So the biceps agonist contracts, the tricep antagonist inhibits. Now, does any part of that feel unclear to anyone? Feel free to speak up. You know, you can speak up if it is unclear. So that is called, since there's an antagonist involved, that's called, how come I'm writing it down like so far away? That's called reciprocal inhibition. Reciprocal inhibition. It should be much closer. I don't know why it's so far away. Oh, I see, because I wanted to go through all this. I see. Okay. Reciprocal inhibition is where the antagonist is inhibited. It's where the antagonist is inhibited. Here's a couple slides which give you a little bit more information, or just a few different views, because I want you to really be able to picture in your mind the intrafusal fibers, and also information on the afferent and efferent neurons, because they're definitely going to expect you to know the terms afferent and efferent. So, Rosie, which impulse arrives at the central nervous system? Is it the efferent with an E or the afferent with an A?
The afferent with A.
Yeah, afferent with A. And which one, humor me, which one exits the central nervous system? Is it efferent with an E or afferent with an A?
Efferent with the E.
That's right. What is the nature of an efferent impulse, motor or sensory?
It's sensory because I think effort is motoring.
The efferent is motor, yes. And
Yeah.
which one provides sensory impulses, afferent fibers or efferent fibers?
The afferent.
Good. I'm going to get you one day, Rosie. Not today. Good work.
Okay.
So now, my recommendation is that you drill the anatomy and the function of the 5 structures we covered. Okay, so let's go over them. So so everybody mute yourselves and repeat after me. So this big belly here, the belly, what is that? Is that extrafusal or intrafusal? That's extrafusal. And then the smaller muscle fibers that are inside that sense stretch, that's intrafusal. The wrapping around the intrafusal fibers, that's the spindle. That's the spindle. The tendon down here, there's a tendon down here, and that's the Golgi tendon. We have yet to really cover that in depth. And then there are fibers, there are neurons which wrap around the intrafusal fibers, and those are sensory. Afferent, letter A, sensory neurons. Afferent, letter A, sensory neurons. I want to see mouths moving. Afferent, sensory, letter A, neurons. And then the nerve impulses that cause contraction, those are carried by the efferent, letter E, motor neurons. Efferent, letter E, motor neurons. Okay. Here's just another rendering, right? So you have the intrafusal muscle spindle fibers or muscle spindle cells. You have the spindle itself in kind of like orangish. And then the big belly is made up of the extrafusal fibers. They will sometimes on the MBLEx, or they will sometimes use the word fibers and cells interchangeably. So they'll say intrafusal cells, intrafusal fibers, same thing. That's how they did it in the e-guide. They referred to the intrafusal as intrafusal cells rather than fibers. And here's another rendering, right? Extrafusal on the outside. Here's the spindle on the inside, and inside the spindle are the intrafusal fibers. And you have nerves carrying efferent, letter E, efferent impulses, and nerves carrying afferent, letter A, afferent sensory impulses. What's that say over there? That says stretch and speed of stretch. Yeah, the role of the intrafusal fibers is to detect stretch and speed of stretch. Okay, now we're going to cover the Golgi tendon organ. Can you raise your hand if you want or need a break before we do the Golgi? Okay, excellent. Okay, let's take a break. Let's take a 10-minute break. 10-minute break. So it's 12:06. Come back at 12:16. Come back at 12:16. See you guys in a minute. Please let me know if you cannot see the screen, okay, or if there's any sound problems. All right, so every muscle has a tendon, and has 2 tendons at least. Excuse me. And just as the intrafusal muscle spindle fibers have to sense stretch and the rate of stretch, it's the role of the tendon organs to sense the load or the weight or the amount of the load. So, if you think about how we injure ourselves, I have an echo in my headset, and it's really messing with my ability to think. I see what's happening. Okay. If you think about how we typically hurt ourselves, how we typically tear muscle fibers or tear tendons or soft tissues like that, it's either through things happening too quickly, the length of the muscle changing too quickly, or through trying to load the muscle with something that is too heavy, trying to pick something up that's too heavy. Oftentimes it's a combination. So it's you know, for example, with biceps curls, for example, it's not usually when people are curling upward that there's a tear. It's often when they start to lengthen the muscle. It's through the eccentric contraction that people tear their biceps tendon, which is particularly nasty injury. So it is a very real possibility that the body can sustain tears of that nature, and it definitely has to be mitigated. So what's happening is, okay, so this is just going to happen this way. Same system. All right, that's fine. The way that we guard against tearing muscle fibers through movement, through stretch that is too quick, is through the intrafusal muscle spindle fibers. The way that we guard against tearing the soft tissues meaning tendons and muscles, tearing the soft tissues through as a result of load that is too heavy, is through the Golgi tendon organs. Whereas a load that is stretching a muscle too quickly, lengthening a muscle too quickly, it causes us to shorten, or we need to shorten the muscle. If we're loading the muscle with something that's too heavy, we need to suddenly lengthen the muscle. So the inhibition is reversed with load that is too heavy compared to stretch that is too much or too fast, right? So and both of these reflexes can be overridden, by the way, through training. If you move heavy weights, or if you practice stretching or quickly lengthening the muscle over and over again, you build you like turn your nervous system's responses, your inhibitions off, and that's how dancers can you know, jump and jump and jump and jump and jump all day long, and they're fine. And then one of us who isn't used to jumping like that could very easily tear fibers in the gastrocnemius muscle. That's how that kind of thing happens. That's how weightlifters are able to move very, very heavy loads without tearing things, whereas people who are just beginning in a sport like weightlifting more easily sustain injuries like tears. Okay, so Golgi tendon organs, which I'll refer to sometimes just as the Golgi. Golgi tendon organs, as their name suggests, is located inside the tendons of the muscles. Their job is to sense the tendon stretch force and to inhibit contraction in the same muscle. And the inhibition is called autogenic, because it's the agonist that's being inhibited, not the antagonist. So force can be a result of the amount of weight. For example, when someone tries to achieve their 1 rep max, that's to lift the heaviest amount that they're capable of lifting one time, or it can be a result of fatigue. So lifting a moderately heavy rate a maximum number of times before you can't lift it anymore. That's called, for example, a 10 rep max or a 12 rep max, whatever that number is, right? So either weight or fatigue. So overuse can cause the Golgi tendon organ to kick in and you drop a weight, or a weight that is too heavy can cause the Golgi tendon organ to initiate autogenic inhibition and drop the weight. We remember that reciprocal inhibition is where the antagonist is inhibited. We saw that with reflexes. We saw that with reflexes in the bicep, where the bicep is the agonist and the tricep is the antagonist. The tricep is inhibited so that the bicep can shorten. Or in the leg, where the rectus femoris is the agonist and the hamstring is the antagonist. The hamstring is inhibited and the rectus femoris is activated. there's a word that I need to introduce to you, which is activation or activate or activated. So when an agonist contracts, it's activating. When an antagonist relaxes or lengthens, it's inhibited. So activation and inhibition are opposites, just like agonist and antagonist, or contracting and relaxing, or shortening and lengthening. Those are all opposites, activation and inhibition. Okay, so what is this? Yeah, so this is just reminding you, this is going over what we established earlier, which is that the afferent sensory intrafusal muscle spindle fibers are responsible for reciprocal inhibition. Reciprocal inhibition, and that inhibits the antagonist, activates the agonist. There's that new word, activates the antagonist. Let's see. Reciprocal inhibition, RI, activates the rectus femoris and inhibits the hamstrings. Here's an example I didn't discuss with you. Examples are good. They help us learn. So in running the central nervous system, it alternately contracts and relaxes the agonist and antagonist, or the opposing muscles. So it's contracting the rectus femoris, relaxing the hamstring, contracting the hamstring, relaxing the rectus femoris. And that allows us to run in a way that's fluid and safe, alternating hamstring and rectus inhibition and activation. Golgi tendon organs, they provide sensory, so sensory receives stimulus, receives information about stimulus, and sends that information to the central nervous system. So it receives sensory information about the load. They initiate autogenic inhibition of the agonist of the same muscle that's being loaded. A good example is squatting too heavy. Autogenic inhibition will shut off the rectus femoral muscle, and that prohibits us from moving the weight. So with reciprocal inhibition, what we saw was the rectus femoris contracting and the hamstring inhibiting to allow the contraction, the rectus femoris activating and the hamstring inhibiting. And we're going to watch a short video now of this guy, Max Aida, who's missing a squat. So he's failing to move the weight. And what you're going to see is this tab is playing audio. Okay. So right there he misses it, and then they help him up. So what's happening is that you get the big load, 270 kilograms. That's close to 600 pounds. He's got this big load on his shoulders, on his back. He squats down, and as he's squatting down, the rectus femoris is starting to lengthen, and it's getting loaded with weight. At first, the load is going down through his bones, into his feet, into the ground, right? But as he bends the hip and knee, the rectus femoris has to work. The load is so much that when he tries to contract the rectus femoris, which straightens the knee and hip to stand up, when he tries to contract the rectus femoris, his central nervous system says, no, this is going to tear. And he misses. He fails to stand up. That's when his spotters on either side, they grab the weights and help him up. Right there. See that?
That's really
last time.
Come on, Max.
There's a miss. And the spotters help him up.
That's really
Okay. Is that clear, autogenic inhibition? Is that unclear to anyone? Okay, awesome. Remember that afferent and efferent can be memorized or identified by their letters. So afferent arrives at the central nervous system, efferent exits the central nervous system. Also remember, when we talk about the central nervous system, we mean the spinal cord and we mean the brain, right? So we don't often think, for some reason, maybe, I don't know, maybe it's just me, but I think we often think of receiving sensory information and sending out motor information as the job of the brain. but it happens in the spinal cord as well. You can think of the spinal cord as like an extension of the brain, or like a long, simpler brain. It doesn't have the consciousness, decision-making that the brain has. It doesn't have the emotional centers. It doesn't quite regulate homeostasis the way that the brain does, but it definitely can respond to reflexes very quickly. And that's one advantage of the spinal cord, is that if you have something from like the lower body, for example, that comes into the lumbar spinal cord, it doesn't have to travel all the way up into the brain and back down in order to initiate a reflex. So that is a survival aspect. You know, I often wonder, did our bodies develop these kind of like smart geographical configurations to survive better, or are we just the ones who survived? You know, it's just an interesting chicken or egg question. Yeah, more information about afferent or efferent neurons. I'm not going to go over all this, but if you want to explore it, you can. One thing that I will point out is that sensory afferent, letter A, sensory afferent information is collected from the organs in the skin, the organs in the blood vessels, the sensory organs in the skeletal muscles, the bones, right? And also the motor impulses, efferent impulses, are sent to the skeletal muscles and all these other, you know, blood vessels, which sometimes contract, arteries contract and relax, and to the skin, you know, pores opening and closing, initiating sweat gland activity, etc. Okay. Yeah. I won't go into the dorsal root and the dorsal root ganglion, although I do want you to know that a ganglion is an area where lots of neurons gather. Usually it's the nerve bodies of the neurons, but you don't have to remember that. I just want you to know that a ganglion is an area where lots and lots of neurons gather, and that's so that they can like pool information or share information. And a ganglion is also a good area where nerves can split. Right. So if you look at the spine, you see like lots of little ganglions on either side. And then from one ganglion, like 2 or 3 larger nerves will come out and then go down the arm, leg, etc. Maybe we'll look at that another time. Okay, this slide I should explain a little bit. So this is something which is useful for you to understand as a therapist. So clinically, and some of the languaging, like nerve impulse being an action potential, you know, motor neuron being a nerve, excites or excitation, neuromuscular junction. Some of that vocabulary is going to be useful for you. It may come up in the context of a question, but according to the FSM-TB, they're not going to ask you any of this specifically. The neuromuscular junction, the excitation of muscle fibers, that's not stuff that you need to know for the MBLEx. And that's in the, you can review all that. You can look at all that if you go to the FSM-TB e-study guides. And I believe that's in the anatomy and physiology under the muscles section, maybe in kinesiology, but you can look at that at any time. Okay, we started with this, understanding the effects of massage on the nervous system. There's the microscopic or the histology. Histo means tissues, and ology is the study of. So the study of the finest aspects, smallest aspects of the tissues, histology. Now let's look at, oh yeah, we got to look at this wacky stuff. All right. So just want to remind you that there are 2 or 3 ways of looking at or describing the differences between different kinds of muscles or classifying muscles. One is through the type of muscle. So generally there are considered to be 3 types of muscles in the body. That's skeletal muscle, cardiac muscle, and then smooth muscle. And that is one way of organizing it. Another way of organizing it is by morphology or morphological. So morph, like when you change, it's the shape of something, how something's configured. So that's whether it's striated or non-striated, striated or smooth. And the third way that anatomists and kinesiologists like to classify muscles is by function. So that's voluntary versus involuntary. So voluntary, again, is anything we have conscious control over, we decide. Involuntary is any muscle contraction, relaxation that we don't have to think about, we don't have to decide to do. And that's one of your objectives for the muscular anatomy and physiology section for the MBLEx is describing the differences between skeletal, smooth, and cardiac muscle fibers, right? Oh, cardiac muscle fibers are striated and involuntary. Skeletal muscles are striated and voluntary. Smooth muscle are non-striated and involuntary. Here's another objective. Understand the anatomy of a skeletal muscle, identify the various organizations of the muscle fibers. So just for like a macroscopic view of the muscle to try to satisfy the answering of this question, we said earlier that a muscle has a belly, also called a gaster, but there's the belly of the muscle, that's the part in red. And then on either end, there's a tendon on either end. And one tendon attaches to a stable bone, like the pelvis is very stable, for example. That's the origin. And the other inserts on a bone that is more movable, more motion. That's the insertion. Tendons can be spelled with an O-N-S or with an I-N-S. They're the same. Tendon or tendon, they're the same. And I just want you to know what they're made of, which is primarily collagen. Collagen is therefore important in the repair process of injuries and the maintenance of the body. And something interesting is that tendons actually are made up of or grow out of the cell wrapping or the sarcolemma of the myofibers, the muscle fibers. They attach or grow out of the sarcolemma. I don't think they're going to ask you that, but it's kind of interesting. All right, levers in the body. So, and I wish that I could have left this one alone. I'll be here all night. So there are 3 classes of levers. It looks like I only have 2 classes listed, which is, okay, I'm not sure how that happened. All right, so, so the first lever, is, the most common is class 3 or third class, class 3. And an example of class 3 being the most widely distributed can be found almost anywhere in the body. The one that's commonly used is the bicep. If you consider that, let's look at the axis first. If you consider that the axis or the fulcrum is the joint, here the elbow joint, and consider that the muscle is effort or force, I'll just say muscle, it provides effort and force, right? Then you can see that the setup of class 3 lever is with the axis at the end and the muscle in front of the axis and the weight in front of the muscle or at the other end. So it's the axis and then the muscle in front of the axis and then the weight in front of the muscle. Another way of saying that is that with the weight on one end and the axis on the other end, class 3 lever puts the muscle in the middle. The muscle's in the middle. So that's the case for almost every muscle in the body. And I just want you to remember that with a class 3 lever, the muscle is, you could say, no, this is incorrect. The muscle is in front of the axis or the fulcrum, and the weight also is in front of the axis or the fulcrum, or the muscle is between the axis and the fulcrum. All right, and then with a class 1, like the second most common lever is class 1. So an example of class 1 lever is the tricep muscle. So if you look at the tricep muscle, you see that, let's look at this one because in this one, the tricep is active and in this one, the bicep is active. You see the difference? Here, the bicep is red and shortening, and here the tricep is emphasized red and shortening. So if you consider that, again, the elbow joint is the axis or the fulcrum, in a class 1 lever, the muscle is behind the axis. So it's the muscle and then the axis in front of the muscle, and then the weight in front of the axis. Another way of saying that is that the axis is between the muscle and the weight. The axis is between the muscle and the weight. So muscle is behind the axis, the weight is in front of the axis. Yeah. And the first class levers include, man, I thought I had all these graphics. I think I must have trashed them inadvertently. A few examples are the low back. So I'll just show you what the low back lever. Actually, let me get the graphic up right now. So low back class 1 lever. Yeah, so in the deadlift, which is where you bend your hips, you bend the hip joint, and you emphasize bending the hip joint more than bending the knee. Like you think about the hip and the low back more than you think about the knee. In other words, in this, the axis is right here in the hip joint. Axis is here. The force is the force is the posterior chain behind the axis. The muscles are stripped away, right? So it's the hamstring muscles, the glutes, right? And then the weight is in front of the axis. So you have the muscles here. In front of the muscles is the axis or the fulcrum, and then in front of the fulcrum is the weight. And then with the head, let's see, C1 skull. With the atlas and the skull, there's also a class 1 lever. And that looks like this. So here the axis is between the first vertebra, C1, atlas, and the skull, right? And so the axis is right here, and the weight is in front. So the chin and the forehead are the weight, and we're lowering the head down into flexion, which means that the muscles on the back are the ones contracting eccentrically, just like in the deadlift, just like with the tricep. Well, not just like the example we saw with the tricep was concentric. Okay, anyway. So the force, the muscles are in the back behind the lever, behind the axis, and the weight is in the front, and the axis is between the muscles and the front. So this is a class 1 lever. Class 3 lever is the least common. There's only one kind. There's only one place in the body that happens. And that is between the gastroc and the toe. Yeah, right here. So with a class 3, with a class 2 lever, the axis is in front. The weight is in the middle, and the muscle is on the other end. So you have the axis in the big toe. You have the muscle or the effort on the other end, and the weight is in the center. The weight is coming through the body down through like the midfoot here. So class 3 is axis on one end, muscle on the other end, and weight in the middle. And the only example for class 2 is plantar flexing with the gastroc or elevating the heel, elevating on the toes using the gastroc. It's the only class 2. Class 3 is the most common with the axis and the weight on the 2 ends and the muscle in the middle. So class 2, axis and muscle on opposite ends and the weight in the middle. Class 3, axis and weight on the 2 ends, muscle in the middle. This is the most common. And then class 1, examples include the skull, where the muscle is on one end and the weight is on the other end, and the axis is in the middle. They couldn't call it most common, second most common, and least common, right? All right, so those are the classes. I believe that's everything for the muscle lecture for this. At this time, I want to review some of the muscle shapes and talk about something I didn't talk about last time, which is the advantages of the shapes. And then we're going to do our range of motion and our joint motions and our planes. Okay. So shapes of skeletal muscles. Parallel fibers or fusiform fibers. They travel in straight lines. An example is the sartorius muscle, the rectus abdominis muscle, rectus femoris muscle, not the rectus femoris, biceps brachii muscle, hamstrings. And the advantage of parallel or fusiform fibers is that they contract over a great distance. So the whole length contracts compared to like a pennate has sections that contract. So they contract over a great distance, so they can cover a great distance. That's an advantage for the longer bones, like the femur, or for long sections, like from the rib cage down to the pelvis. You want to flex the spine or close the ventral area. A straight, long fusiform muscle is an advantage, and they usually have very good endurance, so they don't tire very easily walking, running. But they're not very strong compared to other muscles. They're not as strong as other muscles. So they have good endurance, but they can't move as much weight. They can't generate as much force. Convergent muscles, for example, the pectoralis major muscle, as I forget which one, as someone mentioned yesterday, some of the muscles in the shoulder joint, like the subscapularis and the infraspinatus, they converge to a point. And their advantage is that they focus the force on one point, right? So if there's one area of a bone that they attach to, they exert more, the attaching in a small area exerts more force than if the fibers had attached to a wider area. And then pennate fibers, many fibers for the small amount of area. So there's unipennate, that's the extensor digitorum longus. That's also called the peroneal muscle. There's bipennate, which is the rectus femoris muscle, and then there's multipennate, which are the deeper fibers of the deltoid muscle. So with the pennate muscles, there's many fibers per unit area or per small area. And these are very strong, but they don't have good endurance. They tire out quickly. Compared to the fusiform or parallel fibers, which have better endurance, but they're not very strong. And then the circular fibers, they surround an opening to act as a sphincter. A sphincter is anything that opens and closes in a circular fashion. So that's the orbicularis oris and the orbicularis oculi. And the advantage of a sphincter is that it allows for a round-ish shape, right? So for the organ of the eye, that's very important. And for eating, obviously, that's very important too. Okay, we got to go through joints at some point. Let's review our ranges of motion, our orientation and our ranges of motion. How do you guys feel about all the muscle stuff we just discussed? Intrafusal, extrafusal, Golgi tendon organs, the basics of levers, afferent and efferent fibers as they relate to muscles, sensory and motor, and then the larger aspects of muscles, like having a belly and a couple tendons, and then the distribution of fibers or the shape of muscles. How are you guys feeling about all that? You pretty good? Great. Okay, so now I'm going to switch. Here. Okay. And I am recording. Okay, good. Hide floating media controls. Okay, so just for your reference, we have 11 minutes. We have about 10 minutes, so let's get a feel for what we can review in one day over 10 minutes. It's got to be further back. Stand. This is like, correct me if I'm wrong, but during class is the wrong time to troubleshoot lighting. Cannot see you guys, but I know someone is laughing at me, probably Rosie. Okay, so frontal plane, please do the movements with me. No one will be seeing you. So frontal plane, also called coronal. If you continue the movement through the frontal plane, you end up at the corona, crown of the head. Sagittal plane, right? Sagittal plane, right? And then transverse plane, transverse plane. So in the frontal plane, we have abduction, abduction, and a deduction, right? That goes for the shoulder as well as for the hip. We also have side flexion or lateral flexion. That's through the neck as well as through the spine and through the hip joints, right? And then for sagittal, we have flexion. So recall that flexion of the shoulder looks like this, right? A lot of people get confused about flexion being muscle shortening or two bones moving towards each other with the shoulder. It's not quite so clear to a lot of us, but this is flexion and this is extension. This is neutral, this is extension, neutral, and flexion, right? So this is the sagittal plane. And then also contained in the sagittal plane are flexion and extension of the elbow, flexion and extension of the wrist, flexion of the fingers, flexion and extension of the neck. Remember that this is called flexion because the anatomical view is this way. It's looking at the body from the front with the palms facing forward, right? So this is flexion through the spine. This also is flexion through the spine and extension through the spine. And then flexion and extension through the hip joint. Those are all sagittal plane movements. All right, and then horizontal plane or transverse plane includes horizontal abduction, horizontal adduction, also sometimes called cross flexion. This way is called cross flexion, and rotation through the spine, anywhere through the spine, rotation, and then rotation through the hip joints. Oh, I forgot to mention that the sagittal plane for the lower body, the sagittal, is that the sagittal plane for the lower body includes hip flexion and extension, as well as knee flexion, knee extension, plantar flexion, and dorsiflexion. Okay, great. So now let's go through. Those are our planes. Now let's do our orientation terms. Can you guys hear me okay when I'm facing this way? Can you hear me all right?
Yeah.
Yes.
Okay, awesome. Thank you for the feedback. So So for superior and inferior, the pelvis is superior to the knee, but the knee is superior to the foot. The knee is inferior to the pelvis, right? Remember, it's all relative, but superior is up, inferior is down. Lateral is to the side, away from the midline. Medial is toward the center or toward the midline, right? So the adductor group is the most medial of the muscles, and the IT band, the TFL, those structures are the more lateral. The vastus lateralis is the most medial of the vastus or the quadriceps group. The vastus intermedius is in the mediate is in the middle, and the vastus lateralis is the most lateral of the group. Superior, inferior, medial, and lateral, anterior, and posterior. We always look at the body from anatomically neutral. That's this direction. So this is the anterior surface of the forearm, anterior surface of the palm. This surface of the palm is also called volar or palmar. This is the anterior surface of the legs. This is the posterior surface of the legs and body. You have to think about when they describe a movement to you on the MBLEx, when they describe some kind of movement, you have to think about which is the anterior, which is the posterior surface, which muscles are in the anterior, which ones are shortening, which ones are lengthening, which one is concentric, which one is eccentric. So your anterior, posterior, just as your foundation, can be essential for discerning all that. Okay, so volar for the hand, and also dorsal surface for the hand and the forearm. For the foot, you also have a dorsal surface, and the bottom is called the plantar surface, right? So volar for the hand, plantar for the foot, and that goes to plantar flexion and dorsiflexion of the foot. I think that's it for the, distal and proximal. Distal and proximal messes a lot of people up. So proximal is towards the midline or towards the center of the body, and distal is out towards the limbs. Actually, think of proximal as towards the torso and pelvis, and distal as out along the appendages, right? Because we don't refer to this as proximal and the ear as distal. This is medial and lateral, but the shoulder is more proximal than the elbow. The elbow is more distal than the shoulder. So the most distal aspect of the upper limb or of the arm is the finger. That's the most distal aspect. And the most proximal part of the arm is the shoulder. And all of these features are more proximal. All of these features are more distal. And they may ask you, there's a fracture on the arm where your client is injured. It attaches, it's somewhere around the attachment of the deltoid. How would you describe that? Is that proximal to the elbow or distal to the elbow? And the answer would be proximal to the elbow, because relative to the elbow, the deltoid insertion is more toward the center of the body, more toward the torso. So those terms.
Can I ask?
If you're thinking about where to work, like you could say, okay, let's do some kind of hand technique. Let's do XYZ hand technique. Start at the origin of the biceps and move proximally down the bicep, or start at the insertion of the bicep and move. Start at the origin of the bicep and move distally down the arm, or start at the forearm and move proximally towards the chest. Or with lymphatic drainage, you can describe it that way. Go from proximal to distal, or from distal to proximal, right? Okay, so that's it for the orientation terms. Now we're going to work on
I have a question.
some of the joint movements. Let's just quickly go through the joint movements. So flexion. And
Excuse me.
Flexion.
Excuse me. Someone had a question. I don't think he can hear us.
I don't think you can hear me.
He definitely can't
It's
hear.
okay.
Flexion of the shoulder. You'll also hear it referred to as flexion of the arm at the shoulder joint. Whatever. Extension of the shoulder.
I think he don't have the camera facing us or something.
Head at the neck. Extension of the head at the neck. Flexion of the neck. Extension of the neck. Right. Flexion of the spine. Extension of the spine. recall that for the shoulder blades, this is elevation,
Elevation.
this is neutral, and this is depression. Elevation, depression. Pushing forward opens our shoulder blades, that's shoulder blade protraction. Pulling back is retraction. Opening is protraction, closing or squeezing together is retraction for the shoulder blades. Inversion and eversion happens in the foot. I'll just show you quickly. This is inversion, this is eversion. I guess you could remember that with inversion, the foot's coming in toward the midline, and with eversion, it's going away from the midline. Letter E, like eccentric or eversion, sometimes often refers to away. And then pronation for the hands, it's pronation and supination. That's a term specific to the hand and the foot. Pronation, prone to spill, supination, carrying a bowl of soup. And what else we got? Internal and external rotation. Yeah, internal and external rotation. Definitely practice these with the elbow in different positions and with the humerus in different positions, right? So hands like this, right? So I want you to repeat after me. My elbow is flexed at 90 degrees. The back of my palm is facing out or against a wall. I'm externally rotating my humerus. I'm externally rotating my arm. So do this external rotation with the elbow at 90 degrees, internal rotation, external rotation, internal rotation. Okay, now straighten your elbows, extend your elbows, right? External rotation, internal rotation. Don't think about your hand, think about your elbow or your humerus. External rotation, internal rotation. All right, and now put them up in like a cactus or a goalpost. This is a really common one. External rotation brings the hands back. Internal rotation brings the hands forward. External rotation, internal rotation. With the hip, knee, and foot, there's also external rotation. So external rotation points the foot out, takes the knee out, takes the femur outward. Internal rotation takes it in. External rotation, internal rotation. Now bend your hip and knee, external rotation, internal rotation. Straighten your leg, keep your knee flexed, external rotation, internal rotation. External, internal, external, internal, external, internal. Make sure you guys practice external and internal rotation at the shoulder and the hip with at least like 3 different positions every day, because it will be confusing mentally sitting there taking a test in that abstract way. It can trip you up. Okay, and then radial deviation and ulnar deviation for the hand, right? Remember, this is anatomically neutral, right? So this is radial deviation, which is more medial, and I'm sorry, ulnar deviation, which is more medial, and then radial deviation, which is more lateral. Ulnar deviation towards the ulna, radial deviation towards the radius. Okay, I guess class is over now. And then for the shoulder, there's also horizontal and diagonal AB and abduction. So this is horizontal abduction, horizontal abduction. Shucks. Horizontal abduction, and then there's diagonal abduction, diagonal abduction. Midline, so I'm adding horizontally and then I'm abducting or taking away horizontally, right? And then circumduction, and I think that's it. So circumduction, remember the most distal end, distal proximal. The most distal end moves in the widest circle, and the point of the axis is joined to the body at the root of the body. So you have circumduction at the shoulder, circumduction at the wrist and hand, circumduction through the head, neck, circumduction through the lumbar spine and the torso, circumduction through the hip and the leg. And that's it. All right, good job, everybody. Please let me know if you have any questions by text message, and I'll see you on Saturday. I'm getting the videos up, determined to get them all up today-ish. So we'll be seeing you soon. Text me with any questions, okay? and I'll talk to you on Saturday. Okay. Bye-bye.
Bye-bye.